Assalamualaikum and good morning, everyone.
Good morning, doctor.
You know the
Okay, so today we will discuss tutorial number 2 regarding the introduction to transfer function. So last week we have learned about how to use Laplace transform, partial fraction, expansion, and also inverse Laplace transform. And also we have learned about the transfer function. So transfer function basically a function in frequency domain that relates the output to the input. So let's look at this tutorial and let's see how to answer this question. So given the ODE of a system with initial conditions below, using Laplace transform and partial fraction expansion, determine yt. So we have two questions, A and B. So let's go question A first. Okay, so the initial conditions given to you is 0. So meaning that you can just straight away apply Laplace transform and ignoring the extra terms in the table. Okay, so if you remember the table. So firstly, from this ODE, we need to convert into frequency domain using Laplace transform. So using Laplace transform, so we get s squared ys minus 5s ys plus 6 ys and equals 1 over s. Sekejap, Okay, so after this, then you can rearrange the equation to get ys equals something. Okay, so we can write ys equals. Okay, so basically, first you can factorize ys. And then you can write ys and then from here you can factorize the denominator before you can apply partial fraction expansion. So after you factorize, then you can apply partial fraction expansion. And then after you write in terms of fraction, then you can find the value of a, b, and c by substituting the value of s, a suitable value of s. So usually we will substitute the value of s so that based on these factors in the denominator, okay? When s equals 0, so we get the value of a. Okay, so here 1 equals a times minus 2 minus 3. So we get a equals 1 over 6. Then substitute s equals 2. So 1. So s equals 2, we get value of b. So b equals minus half. And then lastly, s equals 3, we get value of c. Okay, so after we get all this value, then we can substitute back into the equation. So ys equals 1 over 6 over s minus 1 over 2 over s minus 2 plus 1 over 3 s minus 3. Then you can use inverse Laplace transform to get yt. Inverse Laplace transform. So yt equals 1 over 6 minus 1 over 2 e 2t plus 1 over 3 e 3t. Okay. Any question?
Sir, yang over 1 over 6 tu kan, dia tak ada T
Tak ada sebab 1 over s kan sama dengan 1 tadi. Sekejap. So 1 over s, so let's say if you have yt equals 1, then ys equals 1 over s. So 1 ni ataupun ut lah. From table, it equals ut. Table dalam nota. Okay, so let's look at question B. Okay, so question B. Okay, so again, the initial conditions are 0, so we can just apply Laplace transform directly, okay? So use Laplace transform. So we get ys, so s squared minus 3s ys plus 2ys equals 2 over s. Then rearrange to get ys. So we get ys equals okay. Then factorize the denominator. And then split them into 3 fraction. Okay, then compare the fractions with the coefficient ABC with the original one, and then substitute suitable value of S. Okay, so use the value of S from the denominator. So firstly, we take S equals 0. So we get 2 equals, we get A, okay? So A times minus 2 minus 1. So A equals 1. And then take the second value of S. Let's say S equals 2. So 2 equals, so when S equals 2, we get value of B. So B times 2 times 1. So B also equals 1. And then third one, S equals 1. So we get value of C. So C equals minus 2. Okay, you can check later. Maybe I calculate this wrongly, okay? And then substitute back into the value A, B, C into the original equation. So you get YS equals 1 over S plus 1 over S minus 2 minus 2 over S minus 1. And then use inverse Laplace transform. So we get YT equals 1 plus E2T minus ET. Okay, any question?
No, sir.
Okay, so I hope you know how to do this using inverse Laplace transform, and also partial fraction expansion. So now let's look at question number 2. So question number 2, consider a system described by the differential equations. So differential equation below. Find the system response YT to an input RT equals e power of minus t ut, assuming 0 initial conditions. So you have this differential equation. So given to you input RT e power of minus t ut. So this input is in time domain. So you have to convert this into frequency domain first. Okay, so use Laplace transform. So RT becomes RS. So E minus T from the table, you get 1 over S plus 1. Okay, so you get the input in frequency domain. And then from the differential equation, use Laplace transform to convert the differential equation into frequency domain. So okay, so use Laplace transform. So we get s squared ys plus 7s ys plus 10 ys equals, so r dot becomes srs plus 3rs. Okay, so after you get the differential equation in frequency domain, rearrange to get the transfer function. Okay, so firstly we can factorize. So if you feel confused, you can do the step one by one. Okay, so factorize. And then rearrange to get transfer function. So transfer function. So transfer function is output over input. Okay. So ys over rs. So you get s plus 3 over s squared plus 7s plus 10. Okay, so this is the transfer function. So the question asks you to find yt. So we have ys and rs here. So rs, you have this from the one given in the question. So you can substitute this into the transfer function. So ys equals s plus 3 over s squared plus 7s plus 10 times rs. So rs is 1 over s plus 1 . Okay, so you get ys. Now you can factorize the denominator and perform partial fraction expansion. So factorize this. So we get s plus 1, s plus 2, s plus 5, and s plus 3. And then split the fraction. And then expand. Okay, and then you can find value of a, b, and c using the value of factors from the denominator. So firstly, if s equals minus 1, so s minus 1, we get a. So compare with this one. Okay, so minus 1 plus 3. So 2 equals a times 1 times 4. So we get a equals 1 over 2. And then if s minus 2, so minus 2 plus 3, we get 1 equals, so minus 2 we get b. So b times minus 1 plus 3. So B equals minus 1 over 3. And lastly, if S equals minus 5, so we get C. So minus 5 plus 3 minus 2 equals C minus 5 here. So we get minus 4. Minus 5 plus 2, so we get minus 3. So here we get C equals negative 1 over 6. And then substitute back into the YS equation. And then use inverse Laplace transform. So YT equals 1 over 2 E minus T minus 1 over 3 E minus 2T minus 1 over 6 E minus 5T. Okay, any question?
Sir, maaf kalau saya nak tanya.
Yep.
Macam mana kita nak tahu tu S equal to negative 1, negative 2 and negative 5, sir? Can you give explanation sikit?
So dari sini, dari denominator ni, kalau S
Okay,
minus
okay.
1, we get 0 kat bawah ni. Kalau minus 2, kita dapat 0. Minus 5 pun kita dapat 0 kat bawah ni. So kita guna value of S supaya denominator ni equal 0.
Okay, faham.
Tapi actually any ABC nanti jadi lebih complicated lah. So to make it easy, kita cari value of S so that the denominator becomes 0. Which is more easy, simple sikit.
Baik, sir.
Juga boleh dapat juga tapi lebih complicated sikit. Okay, any more question before we end this session? Sekejap je hari ni.
Doktor, tanya sekali. After we get S equal to negative 1 and then 2 equal to A.
Sorry,
For 2.
Yang ni dari sini.
Yang S equal to negative 1, right? Okay. Then 2 equal to A.
So dari sini,
darab
comparekan balik this compare ni dengan yang asal ni. So gantikan minus 1. So minus 1 kat sini dapat 2. And then minus 1 ganti dalam ni dapat 1. Dalam ni dapat 4. And then minus 1 ganti sini dapat 0. So tak payahlah. So kat sini pun minus 1 dapat 0 juga. So tak payah tulis lah. Nak tulis pun boleh tapi bila tulis tu baru sedar lemak kosong. Macam tu. So that's why kita guna values yang bawah ni supaya kita boleh eliminate dua ni. And then proses dia repeat lah. Minus 2 akan eliminate ni dengan eliminate ni. Tapi kita dapat yang tengah ni dan seterusnya.
Oh, okay. Thank you, Doktor.
Okay, any more questions? So I hope you understand how to perform Laplace transform and then partial fraction and then inverse Laplace transform. So usually this question will come out in exam, tapi student lupa macam nak buat ataupun terkejut soalan macam ni. Okay? So usually the question will be related to the next lecture, okay, which is this Wednesday lecture. Kita akan derive, we will derive the transfer function from some mechanical system, and then after that we get the transfer function, and then we may proceed with this process to find the YT or system response. So students tend to forget what is suddenly YT from YS, but this actually just applying partial fraction expansion and then if inverse Laplace transform to get the system response. So I hope you understand this and know how to do this. And for this Wednesday lecture, we will see how we can apply Laplace transform to derive transfer function from mechanical system. Okay, so if you have no question, that's it for today's class. See you again this Wednesday, insyaAllah. Assalamualaikum.
Thank you, Doctor.
Thank you.
Sir,
Thank you.
sir,
Yep.
sir, yang calculation ni boleh tak hantar dalam